My name is Igor Bargatin. I'm an associate professor of mechanical engineering and applied mechanics at the University of Pennsylvania. And for the last few years, my group has been breaking the wall of photophoretic levitation. The word photophoresis comes from two Greek words meaning carried by light. So if you wanted to create a photophoretic aircraft, you would only need light to make it levitate. In particular, it could be sunlight, which all of us enjoy for free every single day. Now, photophoretic levitation has been around for more than 100 years, but most of the experiments done so far have focused on microscopic particles, too small to see with the naked eye. Close cousin of photophoretic forces called radiometric forces have been used to create an interesting toy called Crookes radiometer or light mill. In it, you typically have 4 paper vanes suspended on a low friction spindle, and whenever light is shining on those vanes, they will start to rotate very rapidly. Turns out that the radiometric or photophoretic forces are large enough to overcome friction in a low friction setting. However, they're not big enough to overcome gravity and let those paper vanes fly around. Turns out paper is too heavy for that. In my group, in the last several years, we have developed extremely lightweight nanostructured materials, including nanocardboard. And using these materials, we were able to levitate larger and larger structures using nothing but light. Right now, we can levitate structures as big as 6 to 8 centimeters, and there's no reason why we shouldn't be able to increase the size even further going forward. Now that's interesting because it opens the opportunity of creating aircraft that can explore the mesosphere. It's a region of the atmosphere between 50 and 80 kilometers in altitude, and it's the least explored region of the atmosphere right now because the air there is too thin for airplanes and balloons to create lift and too thick for satellites, causing them too much drag. Only rockets can pass through the atmosphere right now, but only for a few minutes at a time. So our goal is to explore the photophoresis mechanism further and optimize it to create new types of aircraft that could allow us to explore and provide new scientific data in this layer of the atmosphere. As we understand the photophoretic forces better, we should eventually be able to create a kind of a magic carpet, a structure that is many meters in size and flying around using nothing but sunlight. And at that point, we should be able to attach useful payloads, such as sensors that could provide valuable scientific data from the mesosphere. However, we also think that the photophoretic effect can be used to create the smallest flying robots here on Earth at the sea level. Currently, the smallest robots that are available are on the order of a few centimeters and use either flapping wings or a rotor, kind of like a small helicopter or drone. Turns out that scaling even further down is extremely challenging for many reasons, including the greatly increased effect of viscosity at these small sizes. However, photophoresis uses completely different physics and in fact works better at smaller sizes. So we should be able to break the wall of size for flying robots using photophoresis as well.